Okay, so welcome to the Noughts and Crosses solution video. I hope you found the Noughts and Crosses game an enjoyable project and managed to work through a lot of the game on your own in order to get a working solution. If there was any part of the project you got stuck with, not to worry, that's what this solution video is for. In this video, we're going to go step by step and get a working game created. So let's begin. First of all, we're going to import a couple of useful functions that we'll later call upon in the project. So as per previous projects, we're first of all going to import the clear_output function, so we can put from ipython.display import clear_output. And the second module that we're going to import will help us randomly select either player 1 or player 2 later in the project. So for now, I'm also going to import the random module. And this will do for our imports section. Now it's worth noting here that we've only incorporated a couple of modules in each project, but you can import any module you'd like in the import section. So if you find that there's some functionality offered in a specific module, you can import it and utilize that inside your program, providing that you've got the module installed on your machine. And we'll cover the concept of modules and packages in more detail later in the course. So let's now move on to the game logic. Firstly, we're asked to create a data structure that can store noughts and crosses. And there's a clue here if you needed it. You will need to use a structure that contains an ordered sequence for easy accessibility. Now my first thought here is that we need to create a data structure that is mutable. In other words, it can be changed. And it also needs to be an ordered sequence. In other words, we should be able to pick a specific index in this data structure to obtain a specific value. So my mind went straight to constructing a list. So the first thing I will do is actually create a function that enables us to create this list ready for our Noughts and Crosses game. So I'm going to create a function by putting def, and then I'm going to call this function create_empty_board. And then I will put parentheses followed by a colon. Now inside this function, I'm simply going to create a list and assign it to a variable called board. So I'm going to put board equals and then open an empty list. Now if we think about a Noughts and Crosses grid, we have 9 individual segments. And when a player picks a position on this grid, we're going to expect a player to put a number in that corresponds to a segment on this grid. Now the easiest way I can think about doing this is to replicate a keypad, something that you'd see on your computer keyboard, your mobile phone when calling somebody, or even a calculator. So in my list, I'm going to create some empty placeholders. And these empty placeholders will simply be a space. So I'll put single quotes with a space inside as the first element. I will then create 3 rows of 3 for the remaining 9 elements. And the reason I'm doing this is because I can then index element 9 in this list, which will pertain to a single segment in our 3x3 Noughts and Crosses grid, which we know relates to the 10th item in the list. So our first item at index 0 will actually be something we won't use in this game, but it helps in order to create a data structure that can be intuitively accessed when playing the game. Once I've created this list, I simply want to return the variable board. And that will do for step 1. Moving on to step 2. We then need to write a function that can display the board. And we're also given a clue here. We need to access the elements from step 1 to display the board and the corresponding markers. So let's think about this for a second. We've created a function that creates an empty board. In other words, we can access by indexing the list that we created in step 1, but we now need to display the board. And the way that we've been displaying items in previous projects is by simply using a print statement. So I'm now going to create a function called display_board, and what this will do is have one parameter that relates to the board itself, i.e. the data structure that we're creating that stores the elements that go onto the board. So we'll call this parameter board. I can then use my imagination and try to create and print to the screen what looks like a Noughts and Crosses board. So on the first line I can print some empty spaces, and then a pipe symbol with some empty spaces, and then a pipe symbol. I can then on the next line print an empty space. I can then place reference to index 1 of the board that's passed in to this function. And seeing as this will pass in a list, I'm going to access element 2, which will be index 1. I can then put a plus, I can then add some space, then a pipe symbol, then some space. I'm then going to do the same for the second item in our list, which will pertain to the top row middle segment. So I'm also then going to plus, and then board, in square brackets, I'm going to index position 2. I can then put a plus, and then I'm going to put string with empty space, a pipe symbol, and some empty space. And then finally, I'm going to plus board, where we index position 3. And this will pertain to the top right-hand corner of our Noughts and Crosses grid. I can then print something very similar to how we did on the first row. And then I'm going to print some dashes, which will segregate the top row from the middle row. I can now create the middle row of the Noughts and Crosses board. So I'm simply going to copy and paste what I put previously, but this time, where I'm indexing 1, 2, and 3 in the top row, I want the middle row to relate to index position 4, 5, and 6. I can then print some dashes. We'll then do the same for the final row of the Noughts and Crosses grid, and all I'm going to do in this case is change the 1, 2, and 3 to be in reference to the index position 7, 8, and 9. And the index position will be of the list that's passed into this function, which we know we've considered in a parameter called board. So let's run this cell and then test to see if the function works as expected. So I actually created a little test step here where I'm going to run the function with the board input and observe how it looks. So firstly, I'm going to create a variable which is a call upon the function create_empty_board followed by parentheses, and then I'm going to call upon my display_board function and pass in an argument called board which refers to the list that's returned from the createEmptyBoard function. When I run this cell, you can see that we print to the screen something that looks like a Noughts and Crosses grid. Now you can't see any placeholders here with respect to the indexing of the list, but in each of these segments of the grid, it refers to an index position of the empty board. And we'll see how this works shortly when we actually start placing markers onto the grid. Okay, so moving on. Step 3, we're asked to write a function that allows a player to pick either a cross or a nought as their marker. So we'll first of all create a function called player_markers, and we can then put parentheses followed by a colon. Now, seeing as we want the marker to be either a cross or a nought, I'm first of all going to set a variable called marker to an empty string. And then I'm going to use this within a condition that checks to see what is stored inside of marker. So I'm first of all going to start a while loop, and then I'm going to put marker is the same as a cross, or marker is the same as a nought, and then I'm going to follow the while keyword with the keyword not. So in other words, if the marker doesn't contain a cross or a nought, which when we first run this function it won't because it's an empty string, then we want to ask for input from a player. So we can then put a colon, and then we will set a variable called marker. And this will be equal to the input function where we put player1 followed by a colon, do you want to be cross or nought? ? We will then convert this input to an uppercase character, either an uppercase X or an uppercase O. So if the player does not put in an X or does not put in an O, then we will continue to ask for their input until the expected input is given. We then need to return the respective marker for each player, and seeing as these will not change throughout the game, a good data structure to store this result in would be a tuple. So we can then put if marker is the same as X, then we want to return a tuple, which is done by putting brackets, and the first element in the tuple will be the capital X, and the second item in the tuple will be a capital O. If the marker that player 1 chose was not an X, well then obviously they then want to be a nought, so we can put else, return, and the first item in the tuple will be a capital O, and the second item will be a capital X. Okay, so let's quickly test the function we created in step 3. So if we call upon player underscore markers, you can see that we're asked for input, and it says player 1, do you want to be cross or naught? Well, let's first of all pass in some incorrect input. Let's say we pass in the letter P. You can see that we're asked again, player 1, do you want to be X or naught? So our logic seems to be working as expected. So let's say player 1 wants to be crosses. When we put in a cross, you can see that we then return a tuple where a cross is the first element in the tuple and a naught is the second element in the tuple. If player 1 had selected naught, then it would be the other way round. So our function for step 3 seems to be operating as we would expect. Let's move on to step 4. In step 4, we're asked to write a function that takes in the board a marker, either the cross or a naught, and a placement position, which we know is going to be done by placing numbers 1 to 9. We're then told that the function should assign the marker to the position on the board. So let's create a function called place underscore marker, and inside the parentheses, we're going to need some input, whether that be from the user or the program. And the first thing that we're going to need is access to the board itself, i.e. the data structure that we created in the very first step. We're going to need the marker for the specific player, and we're also going to need the position that the player wants to place their marker in. We are then going to put a colon, and what this function will do is simply access the data structure, which is a list and stored in the argument board. We will then put square brackets, and we will then place the position, i.e. the index number for that list, inside the square brackets. So we'll put position in square brackets. And we will set this position of the list, and we know we can do this because it's a mutable object. We will set this position in the list to be equal to the marker of that specific player. And this is all we are going to do for this specific function. So if we test step 4 and run the place marker function and display the modified board, what we can do is we can put place underscore marker, and we can then take in the variable board, which we actually created above, which we know is in reference to create empty board. For the purposes of this function, I'm simply going to pass in a string as the second argument, so we'll pretend that the marker is a naught, and we will place this marker at position 9. If I then put display underscore board and then pass in the board, you can see that we've got a naught in the bottom right hand corner, which pertains to index 9 from our list. If I change the marker to be an X and place this at position 3, you can see that when I rerun this code cell, we then have an X placed in the top right hand corner, which pertains to index 3 from our list. And this is determined based on the display underscore board function that we created in step 2. Now obviously you could have had the index position for each segment in the board to be exactly like a number pad on a telephone, where number 1 is the bottom left and number 9 is the top right. But for this game I went the other way round, where we've got number 1 in the top left and index 9 in the bottom right. Okay, so far so good. Let's move on to step 5. In step 5, we're asked to write a function that takes in a board and checks to see if someone has won. So what this basically means is we need to access the board itself, which is that list data structure that's containing the markers and their specific position on the board. And then we need to write some conditional checks to see if there's a line of markers either horizontally, vertically, or diagonally, which are of the same kind. So we'll call this function winner underscore check. And inside parentheses, we're going to pass in that board data structure, and the second parameter will be in reference to the specific mark that we want to check for. And we can then put a colon. Now we want this function to either return true if someone has won or false if they haven't. So we can simply return, and then we're going to have multiple checks to see if there is a specific winner. So we're first of all going to check to see if index 1 from the board is equal to mark, and index 2 of the board is equal to mark, and if index 3 of the board is equal to mark, we know that the top line in our Noughts and Crosses grid would be all of the same marker, and therefore someone would have won. Or there are other ways that they could win. For example, if board index 4 is mark, and board index 5 is mark, and board index 6 is mark, then they would also win, as they would have created a line across the middle of the Noughts and Crosses grid. And we can copy and paste this and do the same for board index 7, 8, and 9, as this would be across the bottom row of the grid. We can then copy and paste this and check for the vertical lines to see if there is a line of 3. So we can put board index 1 is the same as mark, board index 4 is the same as mark, and 7. If this is the case, then we know that the left-hand side vertically has been populated. We can then copy and paste this, and we'll then check to see if index 2, 5, and 8 are of the same mark. If they are, this would be a line down the middle. And we can then finally check to see if board index 3, 6, and 9 are of the same mark. If they are, this would be down the right-hand side vertically. And finally, there are two other options that could mean that someone has won. This is where we have board index 3, 5, and 7, which we know would be a diagonal line from top right to bottom left. And if a player gets 3 in a line from top left to bottom right, in other words, index 1, 5, and 9, then they would have also won. So this covers every eventuality where a player could win the game of Noughts and Crosses. All the horizontal rows, all the vertical, and the 2 diagonal. So let's quickly check to see if our winner_check function is working as expected. So if we call upon winner_check and pass in the board as the first argument and then a nought as the second, which we know would be the mark that's being checked for, you can see that we get false returned. And that's because if I scroll up, we currently only have an X in the top right and a nought in the bottom right. So if I run this function so we change the X back to a nought, and then place the marker at position 8, and also at position 7, you can now see that the board contains 3 in a row at index position 7, 8, and 9. If I now go back and rerun our winner_check function, you can see that we get true returned. So at this point, if there was a board that had these elements in the list in this order, this function would work out that someone has won the game. Great, just like we wanted, let's move on to step 6. In step 6, we're asked to write a function that returns either player 1 or player 2 as a string. And we're asked to use the random module to randomly decide which player goes first. And we're given a clue here. The method that we're asked to call upon is the randint method from the random module. So let's create a function called player_order, and then we'll put parentheses followed by a colon. I can then have a simple if statement that states if random.randint, and then inside the parentheses of the randint method, I'm going to put 0 and 1, i.e. the choice between 2 numbers. And if I quickly access the documentation, you can see that this method will return a random integer in range A and B, including both endpoints. So it's going to select either 0 or 1. Now, if the random.randint 01 is the same as 0, then I will return player 1. Else, if this function randomly selects the integer 1, then I'm going to return player 2. And this is a fair way of being able to determine who goes first, because it's randomly going to select either 0 or 1. If it's 0, player 1 goes first. If it's 1, player 2 goes first. So very simple, no need to test this. Let's move on to step 7, where we're asked to write a function that asks whether the players are ready. In other words, are the players ready to begin the game? So we'll put the def keyword and then we'll put the function name are_players_ready with a set of parentheses and a colon. We can then create a variable called play_game, and we'll set this equal to an input function where we ask, are you ready to play? ? Enter yes or no. Now if the play underscore game, and we'll convert this to a lower case letter, so dot lower with a set of parentheses, we'll then access the first element of this string and check to see if this is the same as y. Then we will return true. Else we will return false. Now this might not be the best way to do this, because if the player responds with the word yellow to this question, then the game is going to assume that they want to play again, because it starts with the letter Y. So we should add some more control and validations in our code in order to ensure we're getting the right input. But we're going to be tackling exceptions and error handling later in the course, so for speed and simplicity, we're going to leave it like this. So let's now move on to step 8. We're asked to write a function that returns a boolean indicating whether a space on the board is free. So we can create a function called space underscore check, and this needs to take in the board itself, so the data structure that stores all the markers and their respective positions, and then we need to take in a position which will refer to an index that we're checking to see whether the space is free or not. We can then put a colon, and then we just want to simply return true or false depending on whether the space is free or not. So we will return a call on the data structure, so the list board, and then we will pass into square brackets the position that we're checking for. And we just want to check to see if this is equal to an empty string, which we know we've put as a space when we create the board. So if I scroll up to the create empty board function, you can see that we've put spaces as placeholders before the board fills up. So if there is an empty space at one of these index positions, then the space is free. It will therefore return true when we run this function. Okay, so that deals with step 8's problem. Let's move on to step 9. What else are we asked to do? So we're asked to write a function that checks if the board is full. Now, if the board is full, we should return true. And the reason this is an important check is because if the board is full and nobody has won so far, then we know it's a draw. So we'll create a function called full underscore board, and we'll pass in the board, which we know is that list data structure. We will then check every element in the board. And the way we can do this is by doing a for loop on that list. So we can put for I in range, and then we can put 1, 10, which pertains to the start and stop of the loop, where we go up to but not including the stop. So this will go through the numbers 1 all the way up to 9. Then, if the space underscore check function that we've created above, where we pass in then the board and the variable I from this for loop, which we know pertains to the position within the space underscore check function, then we're going to return false. Because if there is a space on the board, then the board isn't full, so we need to return false. But if space underscore check comes back as false, that means there's no spaces left on the board. In other words, it's full, then we want to return true. So by combining these two functions together, we're able to work out whether the board is full simply by checking whether there are any spaces on the board utilizing the prior function. Great, so that tackles that problem. We'll now move on to step 10. We're asked to write a function that asks for a player's next position, and this should be an integer. We already know that we're expecting a position with either values 1 through to 9. We should then check to see if this position is already taken, so we need to utilize our space underscore check function, and if the space isn't occupied, then we need to return the position that the player has chosen. So we'll create a function called player underscore choice, and we will pass into the parentheses the parameter name board, which we know pertains to that data structure hosting the board's elements. We can then put a colon, and we will first of all set a variable equal to 0. Because we know this position within our data structure, i.e. at index 0 of the list, is not being used. So we can then use a while loop that checks to see if the position meets one of two conditions. So while the position is not in the list of integers from 1 to 9, and for simplicity I will simply type these out, so we can put square brackets 1, 2, 3, 4, 5, 6, 7, 8, and 9. So while the position that they've chosen is not in one of those, then it's not a valid entry, or it's already been taken. In other words, it's not space underscore check where we pass in the board and position. So if we think about this for a second, if the position on the board is taken, then this would come back as false, but we want the inverse result, i.e. true, in order for the next line to be executed, so we can put not space underscore check followed by a colon. Then we want to set the variable called position to be equal to the input function, where we're asking choose your next position, colon. We can then give them some guidance, so in brackets we can put 1 to 9, and we will then convert this result, which we know comes back as a string, to an integer. So we'll wrap this in the built-in int function. Now if the position is an integer from 1 to 9, in other words, the first condition returns as false, or there is a space on the board, in other words, the second condition also returns as false, then we want to return that position that the player has chosen. So we're simply building in some control to ensure that we continue asking for the player's position until they provide a valid number. It needs to be either 1 to 9, and if it is from 1 to 9, we need to make sure that that position is free for that player to choose. Okay, great, so that deals with step 10. We simply do a while loop and we keep asking until we get the position, which we then return. Moving on to step 11. We're asked to write a function that operates the game. We're told to incorporate a while loop that takes each player's turn and places a marker on the board. So this is essentially going to be the main game logic, where we incorporate the functions that we've created above to put the specific markers for each player in their respective position. So we'll create a function called game underscore controller, and we will pass in numerous parameters. We'll first of all pass in a parameter called game underscore on. And this will just relate to a Boolean value, which simply states whether the game is on or not. In other words, is the game still going? We will then take in a second argument, which will label the parameter as turn, which tells us which player is placing the marker. We'll obviously need to take in the board itself, and we'll also need to take in the markers of each player. So we'll also have a parameter called P1 underscore marker for player 1's marker, and we will also have P2 underscore marker for player 2's marker. And we can then put a colon. We'll then start the game logic. So while game underscore on, which will first of all be defaulted to true, we can then put our conditional statements. So we can first put if the turn is player 1, then we first of all just want to clear the output from the screen to make it neater when it's displayed. We then want to display the board and pass in the board itself, so we can put display underscore board and pass in the variable board. We then want to set the position that the player is choosing, so we can put position, and this will equal a call on the player underscore choice function, which we know also takes in the board variable. And then we want to place a specific marker, so we can then pass in place underscore marker. This will also take the board. It will take in player 1's marker, which we know is going to be fed in as an argument to the P1 underscore marker parameter, and we will then take the position, which we've stipulated in the line above. We can then check to see if player 1 has won. So we can put if winner underscore check, which is the function we created to check to see if there was a winner, and then pass in the board itself and player 1's marker. Then we will clear the output for display purposes. We'll then display the board again, so we can put display underscore board and pass in the board variable. And then we will print player 1 has won the game. Because if the winner check evaluates to true, then we know that player 1 has 3 in a row. We can then set the game variable to false, which will then break us out of that while loop. Else, if player 1 hasn't won, but they've placed their marker in the last space on the board, we can quickly check to see if the board is full. So we can put if full underscore board and then pass in the board variable followed by a colon. If this evaluates to true, then we want to clear the output for display purposes. We will then display the board again, so we'll put display underscore board and pass in the board variable, and then we can print the game is a draw, exclamation mark. And because the game is a draw at this point, we can break out of the while loop so that these conditions are not checked any further. Else, if player 1 has placed their marker, they haven't won and the board is not full, else we will set the turn variable to equal player 2. Now if we go back to our first set of conditional statements, where we first check to see if turn is the same as player 1, now obviously if we've changed the turn variable to equal player 2, we need a set of else statements, seeing as there are only 2 players. So we can put else, and then we will clear the output, we'll display the board, and we'll pass in the board variable. We'll get the position from player 2, so we can set position equal to player underscore choice, and we'll pass in the board as well. And then we need to place the marker of player 2. So we'll take in the board, we'll take in player 2's marker, and we'll take in the position that's obtained from the line of code above. We can then have very similar conditional statements to check to see if there is a winner or if the board is full. So in the interest of time, I will copy and paste this logic, and I will simply change player 1's marker to be p2 underscore marker. I can now change the print statement to be player 2 has won the game if the winner underscore check function returns true. If they haven't won the game but there is a full board, we can still print out the game is a draw. Else, we will then change the value stored in the turn variable to equal player 1. This will mean that we then go back up to the top of the while loop. Game on at this point is still true, and if turn is the same as player 1, which it would be at this point, the rest of the logic continues. So we've simply incorporated our functions in a procedural way within this game underscore controller function that now operates the game. Moving on to step 12, we're asked to write a function that asks the player if they want to play again. Return true if they do want to play again. Now we've done this many times, so I'm not going to dwell on this for too long. I'll simply put def play underscore again with parentheses and a colon. I'm then going to do this on one line where I return an input function where I ask, do you want to play again? Enter yes or no with a colon and a space. I can then convert this input from the user to lowercase, so I'll put dot lower, which gives us a lower representation of that string that they pass in, and then I can check to see if the string that they pass in starts with, by utilizing the dot starts with method, starts with and then a lowercase y. So if they put yes, this function would return true because yes starts with y, and when this condition is evaluated, we return a Boolean value. If the word entered doesn't start with y, then we will return false. So let's now move on to the final step, step number 13. We're told to use while loops and the functions that we've made above to get the game working. So let's think about how we want this game to be displayed. Well, first of all, I want to print a welcome message for the players. So I'm going to print welcome to Noughts and Crosses, exclamation mark. I'm then going to create a while loop, and I'm going to first of all state while true, which we know means we need to use the break keyword later in this loop in order to break out of this while loop. Now while true colon, we then first of all want to create an instance of an empty board. So we'll create a variable called board, and we'll set this equal to create underscore empty underscore board, which we created all the way back in step 1, and this will simply return a list of 10 elements indexed from 0 to 9. We then want to request the player's markers so we can decide who goes first. So we know we've got a function called player underscore markers, and we return this as a tuple. So if player 1 selects X, then the first element in the tuple will be an X, and the second element will be the naught. So in order to have these in two separate variables, we need to take advantage of tuple unpacking, which we saw earlier in the course. So to access player 1's marker and player 2's marker, we can put p1 underscore marker, comma p2 underscore marker equals player underscore markers. Now because this returns a tuple with 2 elements inside, the first element will be assigned to the p1 underscore marker variable, and the second element will be assigned to the p2 underscore marker variable. We then want to establish what player will go first, so we can create a variable called turn, and we will set this equal to a call on our player underscore order function. So depending on that rand int of 0 and 1, we'll either return player 1 or player 2, and we can then print to the screen turn plus, and then the string will go first, just so that the users who are playing the game on screen know exactly who's going first. We can then ask the players if they are ready to play the game, and we will store the result in a variable called game underscore on. So if we put game underscore on equals, we can then call the function that we created earlier, which was r underscore players underscore ready. Now if they're not ready, this will return false, and the game won't start because the game controller first of all checks to see while game underscore on. So if that is initially false, then the game won't begin. We can then play the game. So we can then call upon the game underscore controller function, and we'll pass in all the respective arguments to the specific parameters. So first of all we have game underscore on, which we set above. We then have turn, which we've also set above. We then want to pass in the board, which we create in the very first line of the while loop. And finally, we want the p1 marker and the p2 underscore marker. And this will enable the 2 players to play the game in its entirety. Finally, we just want to check to see if the players want to play again. So we can put if not play underscore again. In other words, if they've put anything other than yes in the play underscore again function, then we will print hope to see you soon! Exclamation mark. And at this point, if they don't want to play again, we will break out of this while loop. If they put yes, we know that the function play underscore again will return true because it starts with y, and then we will go back up to the while loop, a new empty board is created, they're asked for markers, they're asked for the turn, they're asked if they're ready to play, and then the game underscore controller function will deal with all of that game logic. So at this point, I think we're ready to test our game in its entirety. So let's first of all go up to kernel and then select restart and run all. When I do this, you can see we get caught on test step 3 because where we're testing the function that returns the player's markers, it asks for input, do you want to be X or 0? So we'll simply put X for this just to pass the test case. The rest of the code cells are then run, and we get to the point where we get the message, welcome to Noughts and Crosses. Player 1, do you want to be a cross or naught? So let's say player 1 in this instance wants to be a cross. When we put in a cross, we can see that we're then presented with the message, player 2 will go first. Are you ready to play? Enter yes or no. So let's suppose the 2 players who are playing this are ready, they're going to put yes. When they put yes, you can see that they're then presented with a Noughts and Crosses grid, and they're asked, choose your next position. So this is going to relate to player 2's position, which we know have the naught marker. So let's suppose that player 2 wants to go in the top left, and they're going to put the position 1. You can see that the naught is placed exactly where we expected, and we're then asked again, choose your next position. This time it would be player 1. So let's say player 1 wants to go right in the middle, so they put index 5. It's placed exactly where we expect, and the game would just play out like any game of Noughts and Crosses. So in this first game, let's just make it so player 2 wins the game. So let's say player 2 next goes at index 3. Player 1 is unaware that there's going to be a winner, so they actually go at index 8. And then player 2 sees their opportunity, and they put index 2 to get a line across the top. When they do this, you can see that we get the message, player 2 has won the game, just as we expected. And we're asked then, do you want to play again? Enter yes or no. Let's suppose they do want to play again. Let's put the keyword yes. By putting in yes, we're then asked player 1, do you want to be a cross or naught? This time player 1 wants to be a naught. We're then told that player 2 will go first. Remember, this is randomly generated, so it's just by luck that player 2 will go first on both occasions. Are you ready to play? Let's put in yes. And then we're presented with a blank Noughts and Crosses grid. Choose your next position. Well, player 2 will go first and they are an X. Player 2 will go in the middle to start. Player 1 will then go in the top left. Player 2 will go in the middle at the top. Player 1 will go in the middle at the bottom. Player 2 will then go in the top right. Player 1 will then go in the bottom left. Player 2 will then go in the middle left. Player 1 will then go in the middle right. And you can see at this point, the game is going to end up as a draw. But just to test that our function is working correctly, let's say that player 2 accidentally puts the position 0. You can then see that they're asked to choose their next position again because 0 isn't a valid input, and we built in that control within the functions themselves. So let's now put the correct position, which would be index 9. And by doing this, we unsurprisingly get printed to the screen, the game is a draw. Do you want to play again? Well, we've played twice now, let's say we don't want to play again, so we'll put no. And by putting no, we then get printed to the screen, hope to see you soon. So a fully working Noughts and Crosses game, which has been built by simply creating functions for specific operations that would form part of a Noughts and Crosses game. We've then utilised while loops to ensure that the game logic works as expected, and we call upon the functions in their desired order in very much a procedural way in order to get the desired operations executed in the order we expect. So hopefully you've picked up some new hints and tips in giving this project a go. This was our 6th project in the course, and we're now about to embark on object-oriented programming, which will introduce a completely new way of thinking about how we can design programs. And once we've covered the subsequent sections in this course, we're then going to be able to practice these new skills again, as well as reapply the previous skills that we've learnt in many more projects. The key is to keep applying these Python features in programs and in a practical setting in order to really understand how to design effective programs. Well done on completing all the projects, and I'll see you in the next section.